Alright, welcome. So today we will try as usual solve some coding problem under 40 minutes. Let me see if our stream is up and running. Right, nice. And alright. And this stream is for entertainment purposes only. So without further ado, let's see what's the problem we've got today. So pick one. Is it like dynamic programming again? The k strongest values in an array. A value array I is said to be stronger than value of array j if the absolute difference between the median and this value, so if the distance to the median is greater than the distance to the median for the j. If both are on the same distance, then array A is said to be stronger than array J if it's greater. Alright. Return a list of the strongest k values in the array. And then we have definition of the median. Well, how I see it, we first sort array, get the median, and substitute all values in this array with modular, with the absolute difference between median and every element in the array, and then sort it one more time. So we sort it twice, but again, it's n log n. Once we have it, the only thing is that there might be two Alright, so the first time we just sorted, the second time we sort not the array but the indices of the array, right? And so having those indices, we can then just pick the values from the array itself. The median is the middle value in an ordered integer list. More formally, if the length of the list is n, the median is the element in the position n-1 by half in the sorted list 0 indexed. For this array n equal 5, we sort the median is 6, right? For 4 values, the median is 3, so it's this. Okay, so it's just always this formula, n-1 divided by 2 element, whatever. So then that's what we do. So which one? Quick CPP sort, right? I remember there is several types of sort. What is the fastest sort? Weak ordering. Okay, so weak ordering meaning it should be the fastest. Array begin, array end. So so then int m, we will just compute it once. So it's basically array size -1, right, divided by 2. So now we need the function namespace that will basically return us the vector of indices, right? And this will be m. This is important. So this is sorted array. Sorted array. All right. So I think we can just copy this code from somewhere. I don't want to implement it. CPP sort with indexes. Yeah, I think I googled something correctly like this. Yeah, here we go. Here is a simple template. Stable sort or not stable sort, we don't really care. So we have this vector. And we need stable sort, we just need sort. IDX is sorted array. Oh, let's call it V. Exactly. So V size and then we sort from the beginning to the end using this, right? Absolute difference between V M right? So once we have it, based on comparing absolute dist from median in V. This is technically what we do. All right, thanks Stack Overflow. So once we have this IDX, right? So we say auto IDX Basically we already know what's this. This will be get strongest indexes. So we have this array, and yeah. And again, the array, we don't change the array itself, so we can say it's constant. Alright, so we have this, everything seems to be ready. So now all we need to do is for int I equal what, 0, right? Or actually no, we can just say actually, can we do this smart thing here? So we say if this is less or this is equal, right? Equal and vi2 vi1 itself is less than vi2, all right? All right. So this is it. So if this distance less than this is stronger, or if they're equal, let's say so less, the I2 is stronger, or let's say they're equal and I2 is greater. All right. So now we need to say while, let's have result now, which is what, int result the answer in any arbitrary order, right? Or we can say, all right, so we can say what? Array size minus k Actually, I think we don't need this function at all. I wouldn't delete it for now, just in case. But my feeling is that all we need is just do this, right? Where we have not v, but array, obviously. And we say again. No, let's keep it. Yeah. Because this medium indexes will be, moving all the time, so I don't want this. So let's just use this one, all right? And then the result will be size minus 1 minus k, right? I less than the right size, and I plus plus, and all we do this result, push back, what array of I. No. Of idxi. That's what we need. Right. And then the return result. Alright, let's just run the code and see if it works. Or maybe this is fine. I don't know, I think it would be integer. We always can actually resize t. This is weird. So if k is equal 1, then we just take I think it should be like this first of all, and then because k takes number of elements we want to take, so if we need just one element, then we subtract 1 from size and take the last element. Not the last element, the strongest element. Because it's while, it should be 4. Right, run the code. Ta-da! It works. Let's see if we pass all the tests or not. Yes, we did. Not the most fastest solution though. Interesting. So what if we use stable sort here? It would help. Also, let's look. So we have some time, right? I think we have a lot of time. Yeah, we spent just 20 minutes, so we have another 20 minutes to improve the quad. So, all right, so it's 10 to the power of 5, so 10,000. So 2 to 16 should be sufficient, right? 2 to the 10 is 1,000. So then 11 is 2,000, 12, 4,000, 13, 8,000, 16,000. So 32,000, I guess, or something. And we have 10,000, so it should be fine. Should be fine if you use U in 16T. Here, same here, same here. And M can be also this one here. Then result. Okay, integer is okay. Right. So we've got those indices. We sort the strongest one, and then we just basically added them. Actually, what we can say is this: we can say K, right? And then instead of pushing back, we can say result what? We would save some time. So it's whatever I minus this thing, right? So which is plus K I plus K minus array size. Interesting. So let me check if it still works, first of all. And actually we can say it's constant. All right. But I doubt it will give any benefit. Oh, it's because of this. Let's see. Right, so this still works. Let's just check if it still as slow and poor in terms of memory or slightly better. Something doesn't work as it should. I doubt it's indices. Is it median? No, it's indices itself. So interesting. but definitely is it stable sort? Let me check, because initially it was passing, right? Where is it indices? No, so it's really, it's weird. So 2 bytes were not sufficient. We need 4 bytes, but again, this is unsigned. Whatever. So what about stable sort? Will speed up the things? Slightly better. Alright, so let's submit a few more times to get the best scores possible. At least we solved the problem, so it's okay. How much time we have left? Alright, seems like we can cut shorter today. Not the best in terms of memory though. Better in terms of runtime. Let's submit. Worse memory, worse space. As usual. P2885. Alright. Maybe one last time. Or maybe not. So 316 nanoseconds. So this is the best runtime so far. Whoa. Memory is worse, but the runtime is the fastest one. Alright, so let's stop here. I think we're fine. So we've got, alright, let's also round this up. 27 and 33, right? So it's 60 points all combined. Seven, 33, so 60, All right. See you tomorrow.